So today I'd like to talk to you about percent error. Um, what we're doing is we're taking a quick problem like I'm looking at the back of a Pringles can, and the Pringles can says the following. It says servings per container, and then it says 16. And then it also says, it says 6. And then what it says above that is that serving size is 16 chips. So some quick math means is that the Pringles company, they think Pringles thinks that their chip can should contain 16 times 6 chips. Well, some quick math, 16 times 6 gives us 96 chips. This is the acceptable value. Acceptable values are simply put the value that is the desired outcome. So in the case of the Pringles can, we want to pop until we can't stop and eat all 96 chips. However, these chips are probably sorted by machinery, and so there's going to be some error in that. Like, for instance, let's say I opened up my can of chips and I decided to count all of them. That might take a couple minutes, but it's definitely doable. I mean, worst case scenario, I've got 100 chips in there. So maybe that's not even the worst case scenario, but I'll pretend it is. So let's say that we had 100 chips in that can. With that being the case, what we're going to do is we're going to find the percent error. And here's how we do it. We're going to have to find the difference between the acceptable error and the actual value. So what that looks like is the following. Let's see. The actual minus the acceptable. But wait a minute. What if, and this is a big what if, but what if in our case we've got the actual value of 100 chips, and so that works out fine. 100 minus 96, that's a positive 4. However, what if it were the other way? What if there were actually only 92 chips in my bag, or my can? Well, in that case we'd have a negative 4. But we don't want negative percentages. That just gets confusing. So what we're going to do instead is we're going to keep this, but we're going to have this with an absolute value. Remember that absolute value will make that difference positive, no matter what it is. The actual minus the acceptable will now be a positive value, which is exactly what we want. And we're going to divide that difference by the acceptable value. But that gives us a decimal. We'll have a small number compared to the acceptable value, which means we need to change the decimal into a percent. And we do that by multiplying by 100. So what that means is that when we go to do this problem, we have the absolute value of 100 minus 96, the accepted value, divided by 96 times 100. Doing the quick math, we've got the absolute value of 4 over 96 times 100, and that will equal 4. Absolute value of 4 is 4, so that's 4 over 96 times 100. Oops. That goes up to the top, times 100. And that gets us to the point where we would actually pull out a calculator. Let's see if I can do that quickly enough here. So I grab my calculator and I do the following. 4 divided by 96 times 100, and we find that what we have is a 4.2 or 4.16. Well, let's round to the nearest tenth, but we'll go 4.2. We have an error of a percent error of 4.2%. So once again, acceptable values are the values that we would expect to happen. So like I said, the bag of Pringles, well, the can of Pringles should have 96 chips. A box of Cheez-Its, I've got in front of me, whatever 13 times 27, that should be the number of crackers in the Cheez-Its box. If I buy a liter of Mountain Dew, well, a 2-liter of Mountain Dew, I'd expect it to have about 2 liters in it. But all these things are done by machine, and so there will be an amount of error. And we can find that amount of error by finding the difference between what we actually have and the acceptable value, divide it by the acceptable value, and multiply by 100. Thank you.